Alright, welcome back everyone. I hope you're having a good weekend. Today I want to go over sequences and summation so you can get a feel for how these work. Sequence is just a way to find the nth term of some function. Just call it nth term of some function of n. You can also write that as a sub n. So for the sequence problems, we're just going to write the first four terms of the function. So to do that, for this problem, it says n is greater than or equal to 1, so you're going to start at 1, because n can equal 1. So you just replace n in the function with 1. So you have 3 times 1 minus 1 to the power of 1 minus 1. 3 times 1 is 3, minus 1 is 2, and then the exponent 1 minus 1 is 0. So that's just going to equal 1. And then for a2, 3 times 2 minus 1 to the 2 minus 1 power. That gives you 6 minus 1 to the 1 power, which is just 5. A3 is going to be 3 times 3 minus 1 to the 3 minus 1, which is 9 minus 1 is 8, and 3 minus 1 is 2. So 8 squared is 64. And then the fourth and final term, a4 is going to be 3 times 4 minus 1 to the 4 minus 1 power. And that gives you 12 minus 1 is 11, and 4 minus 1 is 3. And 11 cubed, if you use a calculator, is going to be 1,331. So we have our four terms, and we can write them in order: 1, 5, 64, and 1331, and that's the answer. Alright, for number 2, we're going to use the letter M instead of N and G instead of A, just so you can see that it doesn't really matter what they are, they're arbitrary. So we have minus 1 to the mth power times 2 to the mth power divided by m plus 7, with m being greater than or equal to 0. So we're going to start with 0 for plugging in for m. So minus 1 to the 0 times 2 to the 0 over 0 plus 7. Minus 1 to the 0 is 1. 2 to the 0 power is 1. So you have 1 at the top and 7 on the bottom. For G1, we have minus 1 to the 1 power times 2 to the 1 power divided by 1 plus 7. So minus 1 to the 1 is just minus 1, and times 2 to the 1 gives you minus 2. And 1 plus 7 is 8, and when you simplify, you're left with 1/4. For G2, we have minus 1 squared times 2 squared divided by 2 plus 7. So minus 1 squared is just 1, times 2 squared is going to be 4. So we have 4 divided by 2 plus 7 is 9, and that doesn't simplify. So we can go to our fourth term, G3, and that's going to be minus 1 cubed times 2 cubed divided by 3 plus 7. Minus 1 cubed is just minus 1, so pick up a negative sign, and 2 cubed is 8. Say minus 8 on the top, and then 3 plus 7 is 10. And when you simplify that, you get minus 4/5. So we can write our terms out at the bottom. We have 1/7, minus 1/4, 4/9, and minus 4/5. One thing that's worth noting is sometimes for these problems you'll just be given a series of numbers or a sequence, and you have to work your way back to the original formula, and those are a different beast. I'm not going to show those, at least right now, so we're just going to move on to summation. So summation is just a sequence where a finite number of terms are summed, and for clarity, a series is a sum of an infinite number of terms. So for problem 3 here, you can see the summation notation, which is the sigma from Greek letters, and you have n equals 0 at the bottom, which tells you what number you're starting from, and then 5 at the top tells you where you're going to. So the function is going to be 3n minus 5. So to do this, you just write the terms, plug in the n, and sum everything. So 3 times 0 minus 5 plus 3 times 1 minus 5 plus 3 times 2 minus 5 plus 3 times 3 minus 5 plus 3 times 4 minus 5 and 3 times 5 minus 5. Alright, so if we do the math on these, 3 times 0 is 0, so minus 5 is going to be minus 5. And then 3 times 1 is 3, minus 5 is minus 2. And 3 times 2 is 6, minus 5 is 1. 3 times 3 is 9, minus 5 is 4. Then we have 12 minus 5 is 7. And 15 minus 5 is 10. So we add these together, we get minus 7, and then the positive numbers are going to add up to 22, which leaves us with 15 total. For problem number 4, we have the sum from 2 to 4 of minus 1 to the k times 3 over 2k. So starting from 2, we have minus 1 squared times 3 over 2 squared plus minus 1 cubed times 3 over 2 cubed and minus 1 to the 4th times 3 over 2 to the 4th. So minus 1 squared is just 1 and 3 over 2 squared is 3/4. And then minus 1 cubed, I should write this further out. So we got minus 1 cubed is minus 1, and then 3 over 2 cubed is 3/8. And minus 1 to the 4th is just 1, and 3 over 2 to the 4 is 3/16. So we just want to simplify our fractions. We can multiply the first one by 4 over 4. So we have 12 over 16 minus, we can multiply this fraction by 2 over 2. And that's 6 over 16 plus 3 over 16. They share the denominator. It's 3. And 12 minus 6 is 6 plus 3 is 9. So we get 9/16. For the last problem, we have the sum from 0 to 5 of x over g plus 2 to the g minus 2 power. So for the first term was 0. We have x over 0 plus 2 to the minus 2 power. Next term is x over, let's see, g goes to 1, so we need to redo that. 1 plus 2 to the 1 minus 2 power. We have x over 2 plus 2 to the 2 minus 2 power, plus x over 3 plus 2 to the 3 minus 2 power, and then 4 plus 2 to the 4 minus 2 power, and 5 plus 2 to the 5 minus 2 power. So if we do the arithmetic in the denominators, we get x over 2 to the minus 2 plus x over 3 to the minus 1 plus x over 4 to the 0 plus x over 5 to the 1 plus x over 6 to the 2 and x over 7 to the 3. So we can rewrite this. So we know that 1 over x to the minus 1 is equal to 1 over x, which just ends up being x. Therefore, x over 2 to the minus 2 is 2 squared times x, and 3 to the minus 1 gives you 3x, and 4 to the 0 is just 1, so we're left with x plus x over 5 plus x over 36, and x over 7 to the 3 is going to be x over 343. So if we factor the x out of everything, we're left with 2 squared is 4 plus 3 plus 1 plus 1/5 plus 1/36 plus 1 over 343, which in retrospect is an awful choice. But we end up with 8. Well, x times 8 plus all these fractions. Which, whatever, you can use a calculator. We'll call it good there. Class dismissed.